The video "Garbage Disposal Gone Wrong" (MP4) highlights critical hazards in roadside work, specifically the pinch point vulnerability where sanitation workers operate between a stationary refuse truck and oncoming traffic, eliminating any escape route. High-speed impact dynamics result in immense kinetic energy being absorbed by the rear of the heavier truck and the personnel standing there. A lack of multi-layered protection, such as early warning buffer zones with cones or strobe lights, leaves motorists without cues to slow down. Behavioral gaps like the normalization of deviance cause workers to lose situational awareness, while driver inattention leads to direct collisions. Prevention requires mandatory safety buffers 30–50 meters ahead, technical enhancements like rear-facing cameras, and safe positioning protocols that minimize time spent directly behind the vehicle. Roadside safety must be a systematic approach, as failing to establish a warning perimeter can turn routine tasks into major incidents. The incident in "Why Elevated Loads and Sharp Turns Are a Bad Mix: Safety Tips for Forklifts, Safety Fails Dang Train Chore Day" LinkedIn MP4 demonstrates how violating physics leads to forklift tip-overs. Elevating forks shifts the center of gravity upward, and a sharp turn creates centrifugal force that pushes this center outside the stability triangle, causing an immediate tilt. Because the high load acts as a long lever arm, it generates immense torque and kinetic energy that standard braking cannot stop. Furthermore, an extended mast loses structural rigidity, making it susceptible to twisting forces. To prevent this, operators must never travel with elevated loads, instead lowering goods to 4 to 8 inches above the ground. Reducing speed in tight aisles and wearing seatbelts to stay inside the cabin during a fall are critical safety protocols. Training on load charts ensures safe operation. The forklift incident in Acidente Grave Empel Hedera, a Importancia de Seguir as Regras. MP4 highlights critical technical risks, including severe operator blind spots when transporting bulky loads and the extreme mechanical pressure generated by the machinery's mass during a collision. The absence of active warning systems like proximity sensors or blue spotlights further escalated the danger. This near miss was driven by human factors, such as proximity rule violations and a total communication breakdown between the pedestrian and the operator. Inadequate traffic management allowed foot traffic and heavy machinery to interact without physical separation. To prevent recurrence, management must enforce strict exclusion zones, integrate safety technologies like 360-degree cameras, and prioritize standardized safety training to foster a proactive culture of hazard recognition and accountability. The safety incident analyzed in Machine Safety, Lockout Tagout for Machineries, EEHSS, DANG, Train Chore Day, LinkedIn MP4 highlights critical failures in industrial safety. The worker committed a major error by entering the danger zone while the robotic arm was mid-cycle, underestimating its high-torque program trajectory. This resulted in a mechanical impact where the robot pinned the individual against the safety cage. Technically, the system lacked vital interlock switches and electronic safeguards like area scanners or light curtains, which should have triggered a safety stop upon the breach. To prevent such accidents, strict lockout-tagout (LOTO) procedures must be enforced to ensure energy isolation and the dissipation of residual energy before entry. Implementing internal e-stops and advanced training is essential, as bypassing safety for speed poses life-altering risks.